Welcome to the first pre-release video for your A2 Tectonics and Associated Hazards module. This video is providing visual and auditory support to go with the pre-release lesson 1 notes, which focused upon the formation of the Earth structure, and the characteristic of oceanic and continental crust. The aim of this video is to provide just a visual summary to go with the detailed notes and the tasks that you're going to undertake. It's crucial that you arrive at the lesson having completed the task and learn the information that's been presented in both the video and the document. Okay, so wish you the best of luck. I hope everything makes sense. Please feel free to pause me and stop and start as you need to. And if there's anything you don't understand, then if you record the questions and then bring those ready to come to class, ready to ask those. Okay. So starting with the formation of the Earth structure, I'm just going to give you a very brief background summary of the current geographical and scientific thinking on how the Earth is formed and how this sequence has allowed us to get up to the internal structure that we know of today. So firstly, you need to be aware that the Big Bang theory is taken as the starting point for the formation of Earth. So the Big Bang happened, sending out solar nebula, so hydrogen, helium, lots of dust particles, and these flying around in space start colliding into each other. And over time, as particles collided, they collected together, the heat impact, and you start to get something called planetesimals forming. And planetesimals are pieces of matter that have their own gravity, and as a result they start to attract more material in and they increase in size. So this is kind of the starting point for our planets and for Earth. So about 4.3 billion years ago, the Earth has become a largely molten sphere. So the materials are collected, but it's largely molten, so there's lava on the surface, a really inhospitable place and no life. Then over time, we've got the heavy elements, such as iron, sinking to the centre of the Earth sphere, and lighter elements, such as oxygen and silicon, are rising to the outer surface. Now this sets up this internal layer structure that we've got, and this process of the heavy items sinking to the centre, the lighter materials to the outside, is called differentiation. And basically this went on for a long period of time, and at the end of this differentiation and cooling, chemically and physically distinct layers were then formed. So we have, in terms of its chemical composition, the crust, which is the outermost layer, the mantle, and then we have the core. And as you'll come to see later, we also divide the internal structure of the Earth in terms of its mechanical properties. The diagram here is a typical cross-section diagram that you could be presented with at A2 level of the Earth structure. Now this is quite different to the one that you would have had at GCSE, in that rather than just having the core, the mantle and the crust, there are different terms being introduced, such as the lithosphere and the asthenosphere, and the core has been divided into inner and outer core. But basically, if you're asked anything about the Earth structure, or with the use of a diagram describe the Earth structure, this is the kind of diagram that you should be able to replicate from memory and with detailed labels. So hopefully you'll have a chance to do this in the lesson when we come to it. So each of these layers vary in terms of their chemistry, so what they're made up of, their temperature and the density. And we're going to look at the Earth structure in terms of its composition and its physical properties. This diagram shows how we can look at the Earth's internal structure in terms of its chemical composition and in terms of its physical properties. When talking about the Earth structure in terms of its chemical composition, we can see that it has a core, which is made of iron and nickel and dense rocks. The mantle has less dense rocks and is made up of magnesium, aluminium, silicon, oxygen and iron, and the main rock type is given the name peridotite. And then the outermost layer is the crust, which is lightest of all the layers and contains elements such as silicon, oxygen, aluminium, iron, calcium and sodium. The physical properties approach to defining the layers of the Earth structure follows that it has a solid inner core, it has a liquid outer core, and then the mantle can be divided into an upper mantle, which part of which is the asthenosphere, and a lower mantle, also known as the mesosphere. And then the outermost layer is the lithosphere, and the lithosphere actually includes the crust and part of the mantle. And its physical properties, each of these layers moves in a different way or has a different state. So the inner core is solid, the outer core is liquid, the mesosphere is solid, the asthenosphere is solid, but it's got less pressure and less temperature at the point where it is, so that it can flow plastically, a bit like silly putty can. And then the lithosphere is the solid, rigid outer part of the Earth structure. Make sure that you are aware of being able to describe the Earth structure in terms of both its chemical composition and its physical properties and what they actually mean. So chemical composition is what it's made of, the rock type. Physical properties is the state of the material and its ability to move. I'm now just going to take you through a brief overview of the characteristics of each of these layers. I would urge you to take the notes from the pre-release for this, but this is just showing you, if I'm asking you about characteristics, these are the categories that I would expect you to put it in independently. So in an 8-mark question, and it says describe the characteristics of the Earth structure, you would be expected to talk about a thickness category, a density, a rock type, a temperature, and the state of the rock. So here we have the inner core. Its thickness is 1,200 kilometres. It's the densest layer at 13.6, and it's 5 times denser than surface rocks. The rock type is iron and nickel, and the temperature can reach a range of 5,000 to 6,000 degrees Celsius. And although the temperature is so high, it's the pressure that is so immense that the materials do not melt. So all that rock from the other layers on top of it causes it to actually stay solid despite the high temperature. Following the inner core is the outer core, and the thickness is 2,200 kilometres. The densities decrease slightly to 10 to 12. The rock type still iron and nickel. Temperature 4,000 to 5,000 degrees, and the state is liquid, and it's the movements in the outer core that are thought to be responsible for the Earth's magnetic field. The core is radioactively decaying, which is releasing the heat energy that causes convection currents in the mantle. So basically, from all the collisions that formed the Earth when it was planetesimal stage and it became a sphere, the materials are breaking down, radioactive decaying, and as that happens, that releases heat, and that heat is being transmitted to the surrounding rock through convection. The mantle, so I'm just going to give an overview of the mantle generally, and then I'll divide it into the lower and upper mantle. But the mantle has a thickness of about 2,900 kilometres thick, density 10 to 12, the rock type is peridotite, and it's got lighter elements of silicon oxygen. The temperature closest to the outer core, is 4,000 degrees, and then nearer the surface it goes down to 1,300 degrees. The state is solid, but near the surface, so near the asthenosphere layer, it can flow plastically, which means it's still solid, but it's a bit like silly putty because it's less pressure, less temperature. So now I'm just going to look at the lower mantle and the upper mantle. So the lower mantle, also called the mesosphere on some diagrams, be careful with that because in the weather and climate lessons you'll be having, you'll find that one of the layers of the atmosphere is called the mesosphere, so don't confuse the two terms. They're spelled exactly the same, but they mean different things. And the lower mantle is the zone that extends from 670 kilometres to 2,900 kilometres. It is denser and hotter than the upper mantle because it's closer to the core, and the temperature therefore ranges from 1,000 degrees to 4,000 degrees. It is solid rock as it's so highly compressed that it's got so much considerable strength even though the temperature is very high. Now the upper mantle, and you can see on the diagram that I've shaded in the blue to show the upper mantle and the red to show the lower mantle. So I'm now looking at the blue part, and you can see that I've shaded in part of the mantle, then the asthenosphere and part of the lithosphere. That's what makes the upper mantle portion. So the layer of the upper mantle extends from the base of the crust to a depth of 670 kilometres. The rock is still solid, but due to less pressure and temperature, the rock is more plastic, so it can flow, and this is what causes the tectonic plates to move, because they are floating on top of this plastic part. The boundary between the lithosphere and a sphenosphere is taken to be about 1300 degrees Celsius. Remember, these are approximations, and we'll talk about how we know this information in a future lesson. Lastly is the Earth's structure. This is the thinnest layer, ranges from 6 to 70 kilometres, and this depends on whether you're on continental or oceanic crust. It's the lightest layer, oceanic crust 3.0, whereas continental crust is 2.6. The rock type is basalt for oceanic crust and granite for continental crust, and the temperatures cool range from 0 to 870 degrees Celsius, and the state is solid. It's a rigid outer layer. There are two types of crust, oceanic and continental. You should be aware of that from GCSE. Also, the crust is broken up into 52 tectonic plates, 7 of which are major, and there are lots of minor ones. And the tectonic plates consist of the crust of the lithosphere, the uppermost part of the mantle, as well. Okay, so make sure that you have that information and that you've learned that information, and you should be able to use that to fill in the significant words box. You will only have access to the significant words box next lesson. The last thing to address in this presentation is the differences between oceanic and continental crust. So oceanic crust makes up 70% of the Earth's surface, continental crust accounts for 30%. And what we've got here is a table summarising the differences. Like I said before, with an 8-mark question on the Earth structure, you would be expected to come up with the categories. Again, for contrasting oceanic and continental crust, the categories that are shown in the table here are ones that you should use in your own answers. So you should pick out the thickness, the age, the weight, the nature of the rocks, how they're formed, and the heterogeneity. So thickness-wise, the oceanic crust is thin, whereas continental crust is thicker, so 4 times thicker occasionally. And that's due to the mountain belts that it lies below, whereas the oceanic crust is constantly renewed and destroyed. It's constantly destroyed and renewed, so it doesn't have time to build up in thickness. The age of the rocks, again, the oceanic crust is younger. It's less than 200 million years old, whereas a continental crust, because it's not so destroyed all the time repeatedly, it's over 1500 million years old, and it's older than oceanic. The weight of the rock varies, so oceanic is heavier at 3.0 compared to 2.6. This means that oceanic crust is the rock that subducts when 2 plates meet. The nature of the rocks, oceanic crust is basalt. It's a dark black rock. It's rich in silica and magnesium, and this means it's called SEMA. So Si for silica, Ma for magnesium. Whilst continental crust is made up of mainly granite. This is a light rock which is rich in silica and aluminium. So you've got Si and Al to make seal. But also continental crust is very heterogeneous. Basically, due to the way it's formed, you've got continents colliding, subducting, different processes in the rocks means that you've got a whole blend of different minerals and different types of rocks from different tectonic settings. So it's not just like the oceanic crust where magma comes up and it's one type. You've got a variety of different rocks in continental crust. The way the crust forms also varies. So oceanic crust forms at mid-ocean ridges from basaltic lava rising from the ocean floor due to seafloor spreading, whereas continental crust, you've got volcanic arcs, hotspots. They then go through the rock cycle, being pushed down, melted, coming back up. You've got subduction, etc. So the very different modes of formation, and that gives rise to the very different type of rocks. And lastly, you've got this horrible word that I can't pronounce, but heterogeneity. Basically means if it's a mixture or if it is it evenly distributed, etc. So in oceanic crust, it can be divided into some distinct layers worldwide, so we can work out the rock where it's come from, whereas continental crust, it's going to reflect all different regions of the world and its tectonic history. So there's going to be a whole blend of different minerals, different rock types in there. Okay, so you should be able to compare and contrast oceanic and continental crust using these 6 categories. So this brings us to the end of the presentation. Hopefully this has provided you with just a simple overview to go alongside the pre-release lesson 1 notes, and I've covered the topics of formation of the Earth structure, and the characteristics of oceanic and continental crust. On the pre-release notes there are a number of tasks that you need to complete, and there is also potential exam questions that could be related to this information, and there's also what the examiner is expecting from you. So please make sure you're aware of those, have a look at those, complete the significant words, and be ready next lesson to show your recall of this knowledge and apply it to the exam questions and the activities that I've got designed. Okay. Remember, if there's anything you've got confused by in this presentation and from the pre-release notes, write your question down and be ready to ask it next lesson, where hopefully I'll have the answer for you, or if I don't have the answer, I'll be able to guide you to where you can find the answer. Okay, thank you for listening. Bye.